Oh my gosh, I literally always do that. I'm sorry, you guys. We're lesson number 6. Open it up. Take a look at that warm-up. Which container holds the most? Which container holds the least? We're going to go over it in about a minute and a half. Let me share my screen and we will get started. I want you looking at that warm-up right now, though. Which one will hold the least? Which one will hold the most? And we will go from there. Okay. Thank you for letting me know, Brittany. Okay, I want you to take one more minute to decide which one of these containers is going to hold the least, which one is going to hold the most. I want you to notice that this guy right here is filled all the way to the brimmy brim. Can't hold anything else. Okay. We're going to take another 30 seconds. You're deciding, just deciding which one holds the least, which one holds the most. While we're waiting, I'm going to take a look at the video that we're going to watch that has the answer display. No, wrong button. Okay, here we go. So let's take a look. Which of these containers holds the most? So what we're going to do is this. So it's going to empty out this this mason jar, and then it's going to pour the other two in, and we're going to make comparisons. So just remember that the mason jar was filled all the way to the tippy top. Okay, let's see. There's no sound. It would be cool if there was like some epic, but alas, no thank you. Okay, so I want you to think. Final sort of conclusions. Aiden Gesselman, go ahead. Yes, fill out the little doodad. Who was correct when they made their prediction about the most? Nice job, guys. It was a little bit tricky. Who was correct when they made their decision about the least? You 3, you 4. Awesome job, Aiden. Awesome. So guys, this one wasn't really super like mathy. Yes, but it was just getting you in that frame of mind of let's take a look at these and let's make some estimates, right? Because we're not always going to be able to make choices 100%, right? Sometimes you're going to have to make an estimate, and you're going to have to make a choice, and then you're going to have to back it up. Nice job. All my friends at home did so great. Nice job. I love this. I love, wait, who was that? Let me see. Jaden said he knew it. So you can do it in the math book if you'd like, okay? So we're working in the math book. If you have it, if you don't have it, you can work on the slides, okay? So let's look at our learning targets for today. So we have one really specific learning target and then one more broad learning target, okay? So I can use patterns to write a linear equation that represents a situation. That's our more broad one, where we're going to be looking at a situation, and we're going to say, I need to create an equation based off like where are we starting, what's our initial value, and then what's our constant rate of change. And then we're looking really specifically at, I can write an equation for the relationship between the total volume in a graduated cylinder and the number of objects added to the graduated cylinder. So we're looking at a more specific, a more broad one where we're saying I can create some linear equations, and then we're going to really focus in on this really cool graduated cylinder, adding and like the water level is rising, and we're going to see if we can create an equation for that one as well. So let me just grab my text so that we can look at it together. And let's take a look at so we're at slide number, okay, it's 5. So on slide number 5, it brings us to, it has a link to this tool that we're going to be using. So you guys don't necessarily have to open it at home, but I just wanted to give you the link in case you needed it. So we come here, we're going to scroll down to our rising water levels, okay? And we're going to move the green circle to set the starting level of a value you or your teacher choose. We're going to drop 1 in. When we drop 1 in, with 1 marble, our new water level is how many milliliters? 63. So then now I'm going to drop, don't write it down yet. Don't write it down yet. Now we're going to say when we have 4 marbles in there, what's our water level going to be? 72. Now let's take a look at 5. When we have 5 marbles in there, what is our water level going to be? So let's see if we can. So how many do you guys have in your table now? So we have 0, we have 1, we have 4, and 5. So let's do 1 more. I'm going to drop a few more in. Let me see what happens. I'm going to drop 1 more. Let's get this last data point in here. When we have 9 marbles in, our water level is 78 milliliters. Or 87. Whoa, missed your name. Whoa. That was bad. Okay, so now let's take a look at these questions that we were posed here. So in your textbook, we had to create a table here. We had 1, we said it was 63. 4, we said it was how much? 72. We did 5, had 75. 75. And then we had 9, which had how much? 87. Wonderful. So now, what is the volume V in this cylinder after you add X objects? So now we're talking about creating an equation here. So the volume is equal to what? Our volume is equal to what? Connor. 3x. Adam, what do you think about this equation that we wrote here? He agrees? Because we're talking about the V, our variable V represents our volume, is equal to 3x. Why did you say 3x? Good. So x is not the number, not the weight per milliliter. That 3 is the weight per marble, and the x is the number of marbles you add. Good. And then why did we do plus 60 though, Peyton?
Because that's how much volume there is, and that's the amount of water that's in the tank.
At the when? At the start or at the beginning. Good. It's the initial amount of water that we have in our tank or in our cylinder in this case. Okay. So we're going to explain our reasoning, and we're going to say V is equal to our volume. And we chose 3 because it is how much, or how many milliliters are added per marble. Okay, so we chose that 3 because it's how much weight is, or how many milliliters are added per marble. And then the reason we chose the 60 was because what? It was our
starting volume of water, our y-intercept.
very good. It was our starting value of water. Very good. 60 because it was our start value. Very good. Wonderful. If we wanted to make the water reach the highest mark on the cylinder, how many objects would we need to create, or would we need to add to it? So let's see how many milliliters would take us to the top of our cylinder. So if we look back here, the top of our cylinder is how many milliliters? Abby? 100 milliliters. So we want to make sure, we want to figure out how many marbles are going to get us to 100 milliliters. So if I were to look at my equation that I had, V equals 3x plus 60. How could I find out when would I have 100 milliliters? John, what do you think? So 13 1/3 marbles, and how did you find that out?
I multiply that by 3.
Until you got to where?
200.
100. So we're going to be able to solve this by plugging 100 in where? Abby? V. So we want the volume to be 100. So we're going to plug in 100 for our V is equal to 3x plus 60. So then what's my next step when I want to solve it? Sadie, what do you think? I had to find x, so I want to isolate my x. So first I'm going to do what to each side? Subtract 60, very good. Subtract 60, and I get 40 is equal to 3x. Adam, what do I have to do here next?
Divide 3 by 3 back.
Well, it's not 100 anymore because we did 100 minus 60. So it's 40 divided by 3 on both sides to get x is equal to, someone use their calculator? What do we think, Glenn? Can I add 3/4 of a marble? So how many marbles are going to take me over that 100? How many are going to spill it, Max?
14.
14 marbles. So we want to think about when you're giving me an answer to a question, you need to think about the context of the story, right? So yes, 13.3 is going to be that correct answer, and I'd probably give you half credit for that. But the real answer that I would be looking for would be how many marbles, like logistically, it would be 14 marbles. Does everyone see how I did that? And why I chose that number 14 instead of 13.1? We want to think about like logistically in the context of what is going on, context of what I'm asking you. Okay, so good. Now we're going to look at the bottom here, number 4. So my friends at home, if you don't have a textbook, what I need you to do now is I need you to go back to slide number 5, and I need you to open up this link attached to the image and scroll down until you get to this graph right here. You guys are going to be using your textbooks. The people at home that don't have textbooks are going to be using this graph right here. So you're going to be here and you're going to be flipping back and forth. So let's take a look at number 4. It says plot and label points that show your measurements from the experiment. So we're going to look at this table up at the top here, and we're going to plot some points on here. We had 0, 60. We had 1, 63. We had 4, 72, 74. 5 and 9, comma 87. So on here, this is what I want you to do. If you are in your book here, you're going to plot your y-intercept here. You're going to go, it's going to be a little bit tricky, but you're going to try your best. 9 would be at 67, so I would throw 1 here-ish. And I want you to plot your points and connect them to create an equation. If you don't have a textbook, what I expect you to do is on here, you're going to take those same points on this graph here. You're going to hit the little point, put a point on the 60. 4 was 72, so 70 and 2. And then you're going to grab your line and connect your 2 points. Once you get your line on your graph like this, I want you to screenshot it and insert it into your slide. Okay? So we have our graph. Okay? Now it says the point should fall on a line. Use a ruler to graph the line. So you plotted your points. Now you're connecting those points with a ruler. If you have a textbook, you are plotting those points. Now you're connecting those points using a ruler if you have one. It should create a straight line. Try your best. Okay, so we connected our points using a ruler. Everybody at home, you guys doing okay? You following along? Okay. So let me actually, I just want to align this guy because it's a little bit off and it's kind of bugging me. And I'm like, right? Okay. So, perfect. Okay. So we need to compute the slope of our line. What does the slope mean in our situation? So when we're thinking about computing the slope here, do we actually need to do any math to figure out what our slope is?
No.
No, because what is our slope, Max?
3.
Our slope is 3. We don't need to do any math here because we know that our rate of change is 3, so our slope is also going to be 3 because our constant rate of change is the same thing as our slope. Good. And what does that slope represent in the context of this story? Ian?
How much milliliters is added when a marble is put into the cell?
Very good. How many milliliters? I forgot how. How many milliliters are added per marble? Does that make sense, guys? Hey, guys at home, can you throw in the chat if you can hear me? Because you guys are just really quiet today. I'm not sure if like you're doing it or you're not hearing me or what's going on. So throw some things in the chat so that I know you're there. It's kind of eerie. Okay, next question. What is our vertical intercept? Thanks, guys. What is our vertical intercept? What value is our vertical intercept? Abby, what do you think?
60.
Why do you think that?
Because that's where the line is the y-axis.
It's where our line crosses our y-axis. Okay, very good. Our vertical intercept is the same thing as our y-intercept. I'm going to be using that term y-intercept more often than vertical intercept, but they mean the same thing. The y, both names are sort of intuitive in the way that the y-axis, we know that is the one that goes up and down where it crosses. Vertical meaning that axis that's up and down, that's axis that's vertical, would be for that right there. Does everyone see what we did here? Wonderful. So what I need you to do now in your text is I need you to flip over. We're not going to do the Are You Ready for More? We're going to look right over at 6.3, calculating slope. Let me just erase this. Oh wait, actually, I'm going to ask you some questions before we. You don't need to flip back though, because I'm just going to ask you these questions. So, how does this equation represent the situation that we looked at with the graduated cylinder? So we have this v is equal to 3x plus 60, which is exactly what we found. Good. How does it relate to the story? Who can tell me? Max.
It calculates how much water is in the cylinder after we put a certain amount of marbles in.
Very good. So it tells us the volume after we put X number of marbles into the graduated cylinder. Good. And our V represents our what? Volume. Very good. And our X represents what? The number of marbles you put in there. Very good. Nice job. And so where is our rate of change in the equation? Our rate of change is always attached to our X or our variable. Nice job. Our rate of change is always that number that's attached to our X, our variable here. Good. And what does that 60 represent? The number of what, Kyle? 2 at what time? At the start. Very good. You want to be really specific when you're talking about those numbers. It's the number of milliliters in the container at the start of our experiment. Good. Now, here we go. We are calculating slope. We are given 3 equation lines right here, and we're going to calculate the slope for these 3 lines here. Let me show you what you need to do with this table though. So the vertical change, that means you need to calculate the rise here is going to be that vertical change. The horizontal change is going to be this guy right here. And remember, our slope is what over what? Ian? Rise over run. Okay, so what I want you to do, I'm giving you 5 working minutes. For each one of these, you might need a calculator. I'd like you to calculate, find the vertical change here using these coordinates. Find your horizontal change using the coordinates and calculate the slope for all 3 of the triangles. I'm giving you 5 working minutes right now. Either type it in the slides when you get your answers or write it in your textbook, okay? You're taking 5 working minutes right now to calculate these 3 slope values. finish early, start to think about number 2. So you can look at number 2 in the text, or you can go down to slide number 10. What could be a procedure that you could tell somebody to how to find a slope given 2 points? So if you finish early, start to take a look at number 2. Make sure that you simplify those fractions that you get. So start thinking about an overall procedure. We should not be getting, for that third one, we should not be getting a decimal. So you're going from, so you're going from 1 to 4 seconds. Vertical. Oh, we're horizontal. This guy's going to run from X to X is only 20. Horizontal is 20, and the vertical is 75 minus 35. So there's 2 over n, which simplifies to each fraction. Yep, guys, we're not converting, don't convert things, don't leave things as decimals. Always can leave them as fractions, please. That was the one thing I noticed on the quizzes, that why are you treating things in decimals? Not the best way to go. Yeah. So slope is rising and the vertical over the that's not right. Oh, that's, okay, let's come together. Let's take a look. Okay. So I got rid of a few things here so that we can try to make them a little bit larger so that we can look at them together. So let me just do one thing real quick and then we will be all set. So I want to make sure that I am able to, I'm going to go here and I'm going to duplicate and I'm going to come here. So let's look at A. Okay. So we're looking at A and we're looking at these data points, right? So if we're looking at vertical change and horizontal change, vertical change is going to be the change in our what values? The change in the Y values. Good. And the horizontal change is going to be the change in our X values. Okay? So we have a point here, and we have a point here. We call this Y1, and we call this point 1 and point 2. Okay? So I need to find my Y value changes. When I'm looking at a coordinate coordinates are written x, comma, y. So I'm looking for the change in my second value in each of my ordered pairs. So my vertical change is going to be my y2 minus my y1. So it's going to be 9 minus, what's my y1? 3. So my vertical change is going to be how many units? 6. Very good. Now, finding my x value changes is going to be very similar. But this time we're going to be looking at our x2 minus our x1. So we look at our ordered pair. Ordered pairs are written what, comma, what? Gwen? X, comma, y. So if we're looking for those x values, we're going to be looking at those first values in both of our ordered pairs. So our x2 is equal to what number? 4. Nice job, Abby. 4. And we're going to subtract from that our x1, which is what value here? 1. So our horizontal change is going to be equal to how many units? 3 units. So when we tie it all back together, our slope, if we remember, is our rise or our vertical change over our run, which is our horizontal change. Is rise over run. So what would be my slope for this equation here, or for this line? Peyton? 6/3. Very good. Which, if we simplify that, Cameron, is equal to 2. Awesome job. So our slope here would be 2. So if we go back into our, if you're in your textbook, we're going to go right in that first row in our textbook. If you're on your slides, we're going to come back to the one with our table on it, and we're going to say our vertical change was 6. Our horizontal change was 3. So our slope was, let me just erase some of this ink here. Our slope was 6/3, which is equal to 2. Wait, no, let me put an equal sign. Boom. Okay. That was the first one. That was letter A. Now let's take a look at letter B. We're going to do the same thing again for this one. So let me just move this guy out of the way so I can make it a little bit larger. And let's take a look. Oh, I hit the wrong thing. Sorry, guys. So let's take a look. We have to find our vertical change and our horizontal change. Adam, help me out with this. When I'm looking at my vertical change here, I'm looking at the change in which value, my x's or my y's? My y values. Awesome job, Adam. My y values. Perfect. So looking at my 2 coordinates here, my first coordinate, my second coordinate. How am I going to find my vertical change here, Peyton?
You have to subtract 3.5 minus 1.5.
And why did you choose the 3.5 and the 1.5 as opposed to the 10 and the 2?
Because they're both on the same side.
So they're both in the second position, which in a coordinate pair is the which letter? The x, comma, y. We're looking for our y change, so it's the second value there. So it would be 3.5 minus my 1.5. So what's my vertical change going to be? How many units is it going to be? Let's think. I want to give everybody a chance. Sadie, what do we think?
2.
It's going to be 2 because if you can do this mentally, or if you need your calculator, you have it right in front of you. 3.5 minus 1.5 is equal to 2. So my vertical change is going to be equal to 2. Nice job. Now let's take a look at that horizontal change, which when we think about our horizontal change, that's going to be, we're going to be looking at which values here? Abby? The x values. Nice job, Abby. the x values. So it's going to be, if we remember back, it's going to be x2 minus x1. John, can you help us out? Which value is our x2 value? It's going to be that 10. Awesome job. And from that 10, what are we going to do? Gwen? Subtract 2 because 2 is our x1 value. Awesome job, Gwen. We're going to have a horizontal change of, Cam? A horizontal change of 8. And if we remember, slope is always our rise over our run. So what's my fraction going to be for my slope here? What's the slope going to be for this equation line right here? What was it? 1. So he says 1/2. So after he simplified it to 1/2. How can we write it first? What would be our first step when we write this, Max?
It would be to put the value that we got for the vertical change.
Okay, so what would be my vertical change?
2.
So it would be 2 over 8, which is our run or our horizontal change. And when we type that in, is that going to be equal to 1/2? It's going to be equal to 1/4. Nice catch there. Wonderful, wonderful job. It's going to be equal to 1/4. Awesome job. Thank you, guys. Awesome job. Awesome job, Gabe. Perfect. I like how you caught that, Gabe. Wonderful. So we're going to have a vertical change of, we had a vertical change of 2 and a horizontal change of 8. So we had a slope of 1/4. There we go. Let's take a look at the last one. I'm going to sort of go fast on this last one. Let's take a look. We want to find our vertical change and our horizontal change. Who can help me out with this? Cam.
Well, because it goes x, or if you want to find the vertical change, that's the y after
Yep.
this. So you would have to subtract 75 or 35 from 75.
Very good. So we would say 75 minus our 35 to get a vertical change of how many units?
40.
40. You want to help me with the horizontal change too?
Sure.
Yes.
Because it's the x-axis, and you would go x2 minus x1.
So-
You would subtract 30 from, or 10 from 30.
Very good. 30 minus 10 gets me a horizontal change of, Kyle? 20. And then if I were to write that as a slope fraction, it would be what, Peyton?
40 over 20.
40 over 20, which is equal to, Abby? 2. Very good. So me taking this 10 minutes right now, did that clear how we do it? Good. This was actually, I'm teaching it on a little bit of a different order than I did last year, but I think you guys were just very successful with this portion of the lesson. Awesome job. We're going to do more practice with this moving forward, but awesome job with it right now. Okay? And because I sort of switched up how we went through this right now, we're actually going to skip slide number 13 because slide number 13 introduces to you y2 minus y1 over x2 minus x1. So, boom. We sort of figured it out together before we were even going to go through it together. So we don't need to do that portion of the text. So number 3, we're not going to do number 3. Okay? So we're going to look at our lesson summary for the day. Okay? We're doing our lesson summary for the day, and then you're going to have plenty of time to work on the exit ticket for today. So I want you're taking 3 minutes right now to create and interpret an equation for a situation with linear growth. So you're going to come up with one on your own this time. You can talk about, for example, they gave you have a bucket of water that already has 10 liters. You turn it on, you turn the faucet on and it adds 2 liters for every minute. You could talk about you're getting a gym membership. It costs you $20 down and $10 a month, and create an equation for that. I want you to come up with a story, and I want you to, let me see where I want you to write this. Is there room is the real question. So where I want you to write this is if you have your textbook, in this section that says, are you ready for more? I want you to write it in the graph this equation box, like portion in here. And I want you to write out your equation and situation with for a situation with linear growth. So I want you to be creative. You can talk about a gym membership. You can talk about Amazon Prime. You can talk about a bucket filling with water. You can talk about you're going to the store and you're putting things in a basket at a constant rate. Anything. Be creative. Once you come up with your situation, I want you to try to write an equation that represents it. That's fine, Nassim. Go ahead, buddy. Oh, he was gone 2 minutes ago. That's okay. Two more minutes to come up with your own situation and equation that would be a linear sort of story problem. You're giving me a story problem that shows me linear growth, adding the same amount every single time. You can talk about summer reading. You're reading 20 pages a day. You started with, yeah, if you want to use that one, you can. That might be a good one. Yes. So we're just writing in this space right here. Okay. When can you go to that? Yes, fill out the. So my friends, why don't you, my friends at home, what I want you to do is if you're writing in your textbook, I want you to take a picture of your story and I want you to, like the story problem that you wrote, and I want you to insert it on this slide right here. So get rid of this text box and put a picture of your story in there, okay? Taking 30 more working seconds. Sorry. Okay. Wonderful. Let's take a look. And I'm going to have 2 people share out the story / situation that they wrote about. And then we're going to, you're going to read me the story, and then we're going to see if we can figure out the equation together. Gwen, go ahead.
Okay. Josh is going to the fair. It costs $10 to enter, but 50 cents per ticket for the ride. He wants to go on 10 rides.
Okay. So he wants to go on 10 rides. So can he go on 10 rides? Is that what you're asking?
Yes.
Good. Can he go on 10 rides? So he's going to a fair. So who can help me write an equation based on Gwen's story? So we could start with y is equal to, and what was our constant rate of change in Gwen's story, Abby?
Whatever you
0.5 what? X. Very good. We attach that X because X is the number of what that we buy? The number of tickets that we buy. And that 10 is what? The entrance fee, the initial fee was $10.
Miss Bailey, please call extension 3214.
So Y, her total cost for the day. So her total cost would be equal to 10 plus 0.5, because that's how much each ticket costs, times the number of tickets. Good. Awesome, awesome job, Gwen. That was fantastic. Who wants to read me theirs as well? Who else wants to read me theirs? Junior, I haven't heard from you in a while. Help me out, my friend. What was your story that you talked about?
I said a kid goes to fill up a box with toys. He already has 8 toys, and he adds 2 toys every minute.
Good. So he already had, how many did he already have?
He had 8.
Y equals 8 plus the 2 toys he adds per every X or minute. Very good. Nice job, Junior. Nice job. Your job today, everybody needs to open up their Chromebooks because the exit ticket is not a Google form today. It is a slide on this slideshow right here. So if we look at the slideshow, slide number 16, well, actually, I'm not sure what number it is for you guys because I sort of jumped around, but somebody open it up and let's take a look at that number. Just because I added a few slides in here, so I'm off on my number a
Our
little
slides
bit.
will only go up to 15.
So it's 13. So everybody slide down to number 13, and it says make a sketch of a linear relationship that with a slope of 3 that is not a proportional relationship, and show how you know the slope is 3. So what I want you to do with this right here, I have some points right here. You're going to grab these points and you're going to put them on here somewhere, creating a line that has a slope of 3, and it's not proportional. So where can't I put my point? At 0, 0. Good. You could really put it any other place. So you're going to put probably 2 points on here. Create yourself a line with a slope of 3. And then I'm just going to put these points sort of anywhere because I don't know where my slope of 3 would be. And then you're going to connect them using this green line. So you line it up with one of your points, grab the end of it, and connect them. Now you're going to prove that the slope is 3. So you're going to have to create some slope triangles here. Drag them, create some slope triangles. And label your side lengths. And then just tell me how you knew that the slope was 3. That is your job for the remainder. We have about 2 more minutes left of class. And then homework this evening. You working on that, work on that. I'm going to pull up the homework for this evening. So you have your exit ticket, which was on that slide number 13, as I put here. And then you're going to, on this link right here, you have 5 GeoGebra well, it looks a little bit different because I'm in my teacher mode, but you're going to click on this link here, and there's going to be 5 practice problems that you're going to complete for homework this evening. You're going to use this link right here when it tells you to, it's going to ask you to create a line that has a slope of 3 and a line that has a slope of 12 or of 1/2. So you're going to use this and use these tools here to create a line that has a slope of 3. You're going to take a screenshot and you're going to insert it in there. It's going to tell you how to do it in there. I want you to try your best. Assistance is a little bit tricky, but I want you to give it your best shot. I don't want you stressing if you're really, really not feeling good with this homework. I want you to try your best. If you don't know, move forward. Okay? Does everyone understand what you have to do tonight?
So, do you know where, are we staying here for CCR?
I don't know where we're going.
You want me to go ask her?
Yeah.
Can you just listen for them?
Yeah. Okay, so my friends in here, we're going to head out to Spanish. If you're not in Spanish, I'm going to throw you in the waiting room. Please make sure that you come back here for 11:28 for science. Yep, go ahead. Anybody that needs to go to Spanish, please feel free to go. Quizzes.
She says I'm going to her class, so I don't know what that means for you.
I have no idea what I'm doing. So maybe me and Lynn should just switch. That's what we'll do. Boom. Okay. So quizzes. We will have the opportunity to make up for half of the credits. I expect to see work and corrections made and submitted to me through by next Monday. I'm going to put an assignment up for you to upload your work on, okay? So that will be put up today. You have until next Monday to make corrections to earn half of your points back. The quiz, yes. And I'm going to put up a link for you to upload it to, okay? Yes.
not that I'm saying anything, but I love people, I'm sorry. What are y'all working on? Math work, okay. Do you have homework? Is that what you're working on? All right, do you want to continue working on that? Yes, okay, yes. Did you go when you were in here with Mrs. Jermaine? Okay. People in here? Hi, guys at home. Are you working on math stuff for Ms. Jermaine right now? Can someone unmute and let me know?
Yeah,
No.
she put them all in the waiting room.
There's only one person in the waiting room.
Yeah, because they're on the list.
Everyone else what?
Everyone was stuck.
They left?
Yeah.
Did she tell them to do that?
Well, no, she was like talking about she was saying that's a math lesson. I think they all left there.
Oops.